everyone, welcome to the chemistry channel. So today we're going to be talking about three main topics. So we're going to be talking about molecular compounds, the mole and molar mass, as well as the difference between empirical and molecular formulas. I will have the times corresponding to each one of these topics in the description below the video. Okay, so what is a chemical formula? Well, a chemical formula is a way in which chemists represent the number of atoms in a molecule or a compound. So the chemical formula is a way in which chemists represent the number of atoms in a molecule or compound. So just a quick review, a molecule is the interaction between multiple atoms, and a compound is the interaction between multiple different atoms. So they have to be different from each other in order to be a compound. So in this lecture, I'm going to be focusing on molecular compounds, which are a certain subset of compounds. So molecular compounds refer to compounds that contain non-metals. We're going to get into metal compounds later on. So let's give some examples of chemical formulas that are molecular compounds. So some examples of some chemical formulas that are molecular compounds are methane, water, methanol, and you can go on and on. All of these are molecular compounds, and these are their chemical formulas. So for methane, for example, the chemical formula is telling us that there are 4 hydrogens per carbon. In water, there are 2 hydrogens per oxygen. And in methanol, you have 3 hydrogens connected to a carbon, 1 oxygen connected to that carbon, and a hydrogen connected to that oxygen. So this is telling us basically the different atoms that are connected and the amounts. So that's all a chemical formula is. So these are examples of chemical formulas. So before we go further, I think it's important to talk about the mole. So you may have learned about the mole in high school, and a mole is 6.02 times 10 to the 23rd of anything. So for example, if I had 6.02 times 10 to the 23rd rocks, that would be 1 mole of rocks. If I had 6.02 times 10 to the 23rd feathers, that would be 1 mole of feathers. So the mole, simply put, is just an amount. So the important thing to note about moles is that even 1 mole is always equal to 1 mole, but 1 mole may not weigh the same amount across different substances. So let's look at this example here. So in here I have 1 mole of rocks and 1 mole of feathers. 1 mole of rocks is way heavier than 1 mole of feathers. And this same idea can be applied to the atoms themselves. So for example, we have carbon 12 and magnesium 24. So remember from one of my previous videos that this number at the top is the atomic mass, so how much it weighs, and the number at the bottom is the atomic number. So carbon 12 weighs 12 atomic mass units, and magnesium 24 weighs 24 atomic mass units. But so by definition, 1 mole of carbon 12 weighs 12 grams. So by definition, 1 mole of carbon 12 weighs 12 grams. So by transitive property, 1 mole of magnesium must weigh 24 grams. So the general rule is that, so this is the general rule. The general rule is that the atomic weight of an element in atomic mass units is numerically equal to the number of grams in 1 mole. So that is the general rule that you have to know. So here I have an example of oxygen. So this is how oxygen appears on the periodic table. Here is the atomic weight, and here is the atomic number, which is 8. The atomic weight is 16 atomic mass units, so therefore by the rule above, this must mean that 1 mole of oxygen must weigh 16 grams. So the molar mass of oxygen is 16 grams per mole. So the molar mass is the amount of grams in 1 mole of substance. So if you look at the periodic table, you'll see that the elements have this general look. So let's just use hydrogen for a second for another example. So you'll have an atomic number of 1 and a weight of around 1.01. So this 1.01 for hydrogen means that it weighs 1.01 AMU. But by our general rule, this also means that in 1 mole of hydrogen, that 1 mole of hydrogen will weigh 1.01 grams. So 1.01 grams per mole. And that's the molar mass. So you can also look at these atomic weights at the bottom of each element symbol to mean the molar mass of the substance or of the element. So here I have an example. So here I'm going to calculate the molar mass of this molecular compound. So in order to do this, I have the different molar masses of each element on the side here. So all you have to do is add them up and multiply them by their factors. So we have 3 carbons. So we multiply 3 by 12.0 grams per mole. And then we have a hydrogen, which is 1.0 grams per mole, and we multiply that by 6. And then we have 1 oxygen, and that is 16 grams per mole. So when you add all of this together, you should get around 58 grams per mole. And this would be your molar mass of this particular molecular compound. So let's just make sure we have the correct number of sig figs. We have 3 here, we have 2, and we have 2 here. So therefore our final answer should also have 2. Okay, so now that we have a understanding about the mole and molar mass, we can now get into molecular versus empirical formulas. So the molecular formula is a little bit different from the empirical formula. It indicates the exact number of elements, not elements, so let's get rid of that, the exact number of each of, let's get rid of that, I'm sorry, wrote a little too fast. Okay. Indicates the exact number of each of the atoms that make up a molecular compound. So in other words, it tells us the exact amount of atoms that make up the molecule or compound. The empirical formula is basically the simplified form of that. It only gives the relative amounts of each atom in a molecular compound. Okay, so it's basically the simplified form of the molecular formula. So in order to understand this, I have a little demonstration here. So here we have C2H4. This indicates the molecular formula. So this chemical formula, which is the molecular formula, tells us the exact amount of each type of atom in here. So this particular molecule has 2 carbons and 4 hydrogens. And this actually corresponds to ethene. So it's going to have this structure. And we'll learn how to draw these later on. So this is telling us the exact amount of atoms in this particular formula. So that's the molecular formula. However, in order to find the relative amount of each atom in this molecular formula, you have to divide it by 2 in this case. So you divide it by its common denominator or something like that. So in this case, you would divide it by 2, and this would give us CH2. And this tells us that there is 2 hydrogens for every carbon in this molecular compound. So this is the empirical formula. So it's telling us that there is 2 hydrogens for every carbon. So once again, the molecular formula tells us the exact amount of each type of atom in the chemical form in the particular compound, and the empirical formula tells us the relative amounts. So there's 2 hydrogens for every carbon in this molecular compound. So one more thing before our practice problems. So you can always convert the molecular formula to the empirical formula just by simplifying it down like we saw here. However, you cannot convert the empirical formula to the molecular formula without more information. So you would need something like a molar mass or something else in order to find what the molecular formula is. And we're actually going to practice this below. So that's it for all of the concepts for today. So with that, let's go into our first practice question. So I encourage you to pause the video and try this for yourself. So let's go through this together. So we start off with 10 grams. So let's first actually figure out what the molar mass is of O2. Now O2 is made up of 2 oxygen atoms. So therefore, in order to find the molar mass of O2, all you have to do is multiply the molar mass of oxygen times 2, which would give you 32 grams per mole. And this is your molar mass of oxygen gas. So now we can convert this 10 grams into moles. So let's do a little dimensional analysis. So 10 grams of O2, and we multiply it by our conversion factor. So 32 grams per 1 mole of O2. Okay. So when you plug all this into your calculator and conserving the amount of sig figs, so you have 2 sig figs here and 2 here, you should come up with 0.31 moles of oxygen. Okay? So let's just show the canceling out. So grams cancels out, and we're left with moles. So 0.31 moles of oxygen gas. Okay, so here's the second problem. So what is the empirical formula of C4H10? So I encourage you to pause the video and try it for yourself. Okay, I hope you paused the video. So let's do this together. So our molecular formula is C4H10. So this is our molecular formula. This stands for molecular formula. In order to find the empirical formula, we have to divide by the largest factor that's shared between them. So in this case, it is 2. So you divide by 2, and this gives you C2. Oops, I miswrote this, so this should be H. I don't know why I wrote 10. So C4H10, and you divide that by 2, and that will give you C2H5 as your empirical formula. So you just divide by the greatest common factor shared between these two numbers, and in this case it is 2, so you divide by that, giving you C2H5. Okay? So that's how you find the empirical formula from the molecular formula. Okay, so here's the last problem. So this is the hardest one. So if an unknown species has a molecular weight of 180 grams per mole and its empirical formula is CH2O, what is its molecular formula? And I put all of the corresponding molar masses that you should use here. So I encourage you to pause the video and try it for yourself. Okay, so let's do this together. So the first thing we have to do is find out what the molar mass is of the empirical formula. So the empirical formula is CH2O. So in order to find the molar mass of the empirical formula, what you have to do is add up all the weights of each of these atoms and see what you get. So we have carbon, and carbon is 12 grams per mole, and we only have 1 of those. And then you have 2 hydrogens, and hydrogen is 1.0 grams per mole. And you have 2 of those, so you have to multiply it by 2. And then you have oxygen, which is 16 grams per mole. And when you add all of those up together on your calculator, you should get 30 grams per mole. And we want to conserve the same amount of sig figs, so 30 grams per mole. And that's because each one has 2 sig figs. So 30 grams per mole is our empirical weight. Empirical weight. Okay, so now we have to find the molecular weight. So we actually already have the molecular weight here, so we can use the molecular weight and the empirical weight to find out what the molecular formula is. So the molecular weight is 180 grams per mole. So all you have to do is divide 30 from 180 grams per mole. And this will give you 6. So if you divide these two from each other, you will get a factor of 6, and conserving the amount of sig figs, 6.0. So 6.0. So what do I do with this 6.0? Well, this is a factor by which I can multiply each part of the empirical formula by. So I'm going to write my empirical formula again, CH2O, and all I got to do is multiply each of these atoms by 6. So if I multiply each atom by 6, I get C6H12O6. And in fact, this is the chemical formula for glucose. So that is it for today. I hope this cleared some things up for you, and I wish you all the best and have a good day.